So guys, let's discuss about the water supply systems. We divide the supply system into five categories. The number one, we have the direct supply system. Secondly, we have the direct pump system. And the third one is hydro-pneumatic systems. And the fourth one is transfer pump system that is mostly used. Now the fifth and the last one is transfer plus booster pump system. In upcoming videos, we will discuss each system one by one in detail. Now let's discuss about the direct supply system. In this system, you don't need any extra plumbing equipment to transfer the water into your building. All you need is a pipe, which is the main pipe, which is connected to the city main water lines, right? The city main water lines are already with the sufficient pressure in these lines, right? So by using by the help of these sufficient amount of pressure in these lines, we can transfer the water from the lower ground level to the topmost floor of your building. But in most of the cases in city main lines, we don't have any adequate amount of pressure to get the water from lower level to the topmost floor without the using of the pump, right? So this supply system is only applicable if you have one or two floor building, right? So by using this method, we can conclude that you cannot supply water into the topmost floor of the building. Okay. Now in direct pump system, we have a city main water line. From that main line, this symbol is for you can say that isolation valve. Okay, from that main line we store the water in an underground water tank with the help of a pump. This is a symbol of a pump in this image. Now from that pump we use another pump to transfer the water from underground tank to the entire building. This line represents the supply main pipe. Okay. uh, while moving upward in the direction of the building, we supplied all the floors, okay, from bottom to the top. But there is another thing. We have one more overhead tank. We collect water from that main line, and from this overhead tank, we supply the water into the toilet to the water closets. Okay, because water closets uh, require a water in pressure, so they have flushing tanks installed with the water closets. So therefore we have a separate overhead tank for these fixtures, but for kitchen and other bath and toilet rooms fixtures like laboratories, like showers, we supply from this underground tank. All right, so these are some important lines. Supply to kitchen and bathroom fixtures from ground level, but supply of water to water closets and flushing fixtures from the overhead tank. Okay, so this is all about the direct pumping system. Now we have hydro-pneumatic system. In this system, we have a main water line from the government. We collect the water from that main line in our underground tank with the help of a pump. Okay, and after that we have another pump which supply the water into the building in each floor. But there is a special thing which we install in that system is compressed air line. And yes, that's why the system is called hydro pneumatic, means water and air system. We have a pressure tank. We fill the pressure tank with the compressed air by using the air compressor. In case of water demand, the pumps supply the water from underground tank to the building. But in case of increase in demand, this compressed air push the water from the lines towards the building, which helps the pump to reduce the energy. All right. So this compressed air, the main purpose of installing this compressor to push the compressed air towards the water lines in case of increase in demand. Okay. So this system will help in peak demand because yeah, in this image we have only one pump. In most of the cases we have more than one pump. Like here, this is the actual image of hydro-pneumatic system. In that building, let's suppose this pump is supplying the water. But in case of increase in demand, this pump requires some time to acquire its peak angular velocity or peak rotation. Meanwhile, this compressed air serves the water, and all the occupant in that building will get the equal amount of pressurized fluid. Next, we have the transfer pump system. This is most widely used system in buildings. We have underground water tank, same as we have in previous systems, a pump which used to supply a water which used to supply the water from underground tank to the building. But in this case we have a main supply line which take this water from underground water tank towards the overhead water tank. We have installed two overhead water tanks. Sometimes you can install only one overhead water tank. Now from ground level, you need to collect that water to the topmost floor. Like in this case, we have a terrace over here. We have installed the overhead tanks in the terrace. So after filling these tanks, we can supply the domestic water from those overhead tanks. But in this case, we use gravity to supply the system. We are not using any kind of pump. Right after from the overhead tanks, we directly supply the water with the help of domestic main pipes. These are the isolation valves. So in this image we use two overhead tanks. One is used to supply kitchen and bathroom fixtures apart from water closets. For water closets and for urinals we use, not for urinals, only for water closets we use separate overhead tank, all right, for flushing purpose. That's why we call this pipe as flushing main. So this is about the transfer pump system. Now we discuss about the transfer plus booster pumping system. Let me tell you one thing, this system is same like transfer pump system, but in this case we installed another two pumps right over here. In this image it is not showing any pump because I use same image from transfer pump system, right? I place the same image here in transfer plus booster pump system. There we have two pumps which are used to supply the water to the upper floors. In this case, we have 1, 2, 3, 4, 5, 6, 6 floor and a terrace over here. But let's suppose you have 50-story building, and if you install that system, only a transfer pump system, you can supply water by gravity into the lower floors. Okay, but for the upper floors you will get a low pressure water into your kitchen and toilet areas. To compensate that low pressure you can install two booster pumps after the overhead tanks. that will generate more pressure to supply to the upper floor, right? For the lower floors you can use same system, like you can use gravity system for the lower floors, but for the upper floors you require booster pumps to maintain the pressure. Okay, so one more thing, this pipe is in this system, usually we call it as a transfer pump, and the two pumps that you install over here are usually called booster pumps. Okay, fluid mechanics. All the information about the basics of fluid mechanics will be I will be taking from Practical Plumbing Engineering book, which is by Cyril M. Harris. You can download this book from American Society of Plumbing Engineers bookstore. But as you know, I'm going to use 3 to 4 books from American Society of Plumbing Engineers and International Plumbing Code book as well. So I will not recommend you to purchase all these books for this course, because I will provide you each and every material through this course. So this course will be very handy for you. So I will not recommend you to buy any book, right? But if you still need to read, if you like to read more material, then definitely you definitely you will purchase these books, right? So let's start. So let's start with the definition of fluid mechanics. Fluid mechanics means basically it is the oldest branch of physics, and it deals with the mechanics of fluids, either it is a liquid or gas, and the forces on those fluids, right? So let's move towards what is hydraulics. Hydraulics is, you can say, it is the one section of fluid mechanics. It is basically the part of fluid mechanics, or you can say the sub branch of fluid mechanics, right? And plumbing, when you talk about plumbing, plumbing is nothing but it deals with the flow of fluids in pipes, right? The study plumbing is the study of fluid flow through pipes, and it is a practical application of hydraulics. If you want to see the application of hydraulics, then plumbing is the best example of hydraulics. So basically, when you talk about hydraulics, so hydraulic principles are based on chemical, physical, and mechanical properties of water. So therefore, it is very important to understand all the properties of waters, right? So in upcoming lectures, I will brief you about different properties of water. We will study the viscosity, we will study the density, flow types, laminar and turbulent, the temperature effects, and the velocities of water, right? So let's start with the first property of water, which is density. Density is a very simple thing to understand. It is the ratio of mass of a substance, in our case, mass of liquid or water, to the volume it occupies, right? The formula of density is D equals to mass per volume. Mass is made in pounds and volume in feet cube. As you know, volume has 3 dimensions: length, width, and height. So it will come up with feet cube. So the overall unit for measurement for the density is pounds per feet cube, right? So this table is taken from Practical Plumbing Engineering book, table 3-1, water temperature density correlations. So if you increase the temperature, the density also will decrease, right? But we usually take 62.3 pound per feet cube density during our calculation in plumbing. right? Plumbing calculation density 62.3. But these changes, if you increase the temperature, these are very minor changes. So therefore, we only stick ourselves with 62.3 pound per feet cube density, right? The second most important property of water is viscosity. Let's begin with the definition of viscosity. Viscosity is basically the bonding of molecules of a liquid with themselves, right? If the forces among the molecules of liquid are more, then there will be more viscosity. If the forces of attraction, you can say, among the molecules of liquid or any fluid, or you can say gas, but in the case of gases, we might not consider the viscosity factor. But in liquid, it plays very vital role. So in liquids, if the forces of attraction among the molecules are very weak, so there will be less viscosity. Let me give you an example. We have honey and water. You can see over here that the honey has more thickness, right? So thickness is, in layman language, you can say that it is basically the viscosity, right? Because it has strong intermolecular forces. The honey has more forces of attraction among the molecules, but in case of water, water has less forces of attraction among its molecules, right? So if you compare these two liquids, honey has more viscosity and as compared to water. So the unit for measuring the viscosity is centipoise, and at 60°F, the viscosity of water is 1.12. Now, in plumbing systems, if you deals with hot water or cold water, it doesn't make any change with the viscosity of water, right? So in but if you read the textbooks of hydraulics or fluid mechanics, you can observe that if you increase the temperature, if you rise up the temperature of liquid, any liquid, the viscosity will reduce, right? But in plumbing systems, there will be no significant increase in, yes, there is a significant increase in the temperature when you require a hot water in your toilet or for shower purpose in your washroom. You definitely require high temperature, but that temperature is not significant to you can say reduce the viscosity of your water, right? So in plumbing, if you talk about cold or hot water, the velocity, oh sorry, the viscosity difference is negligible. Now we are going to discuss about the difference between laminar and turbulent flow. We have an image, and in this image the first section of pipe represents the laminar flow, right? You can see over here the flow is coming from left direction and going towards right direction. This liquid is basically water, and we have a straight pipe segment. The red arrowhead shows the streamlines, the direction of streamlines, right? So the direction of streamlines are proper in horizontal direction. So these horizontally direction of streamlines shows that this flow is laminar flow. But in case of turbulent flow, we have irregular pattern of streamlines. This type of flow occurs when we have a restriction between the flow of water, right? If there will be no restriction and the pipe segment is straight, then there will be laminar flow. The turbulent flow usually occurs inside pumps, valves, across rough surfaces, and along fittings. So, as a plumbing design engineer, it is our responsibility that there will be less turbulence in our plumbing system. So therefore, it is very important to understand about the laminar and turbulent flow.